Communication, navigation and surveillance, in short CNS, are the main functions that form the infrastructure for air traffic management. They are essential to ensure safe and efficient air traffic. Communication between aircraft and ground, between two or more aircraft, or to exchange information or data. Navigation is done by the pilot to steer the aircraft safely to its destination. En route, this is done primarily with satellite navigation and ground systems as a backup, but landing is still primarily done with ground-based instrument landing systems, ILS. Surveillance systems are used by air traffic control to determine the position of the aircraft. This is done with radar or multilateration. The three parts of CNS are made to complement each other. In case one part becomes unavailable for any reason, the other two parts still allow safe operations. For example, if navigation fails, the air traffic controller still can see where the aircraft is with surveillance and can give instructions to the pilot accordingly through radio communication. This is rarely the case though, and each part has one or multiple backups in place. Let's go through a typical flight and see how and where CNS systems are used. En route, the aircraft often uses satellite navigation, but it can also fail, for example, due to solar wind disturbance in the ionosphere or other electromagnetic interference. For that reason, as well as to be independent as a country, we have navigation aids on the ground. They are very important as a backup, and older aircraft also use them for primary navigation. Examples of those are the distance measuring equipment, DME, to see how far the aircraft is from the navigation aid, or the VHF omnidirectional range, VOR, which lets the pilot determine his angle towards that navigation aid. The air traffic controller monitors the aircraft by radar to maintain separation to other traffic. Instead of traditional radars, other new technologies are becoming more widespread, using automatic dependent surveillance, broadcast ADS-B. This technology uses many smaller ground stations and is more redundant, as well as less expensive.
Swiss 123, descent flight level 80.
While we all know communication by voice, the air traffic controller can send information electronically to the pilot, which can save time and avoid misunderstandings. This technology is called Controller-Pilot Data Link Communication, CPDLC. The aircraft is going to land soon, and the air traffic controller is going to direct it towards the Instrument Landing System, ILS, another vital type of equipment. It can be used for landing in any weather, like clouds and fog.
Heading 110, cleared ILS approach runway 14, Swiss 123.
While the pilot is lining up the aircraft with the instrument landing system, he can observe how it is guiding him towards the landing runway. In this short overview of an aircraft landing, we can recognize just how important all of this CNS infrastructure is. For an overview of the three CNS domains, let's start with the communication domain. Radio, the voice communication between pilot and air traffic controller. For the air traffic controller to communicate with the pilot, Skyguide has installed radio antennas all over Switzerland, including an emergency backup radio communication system. This is the most important means of communication here. Controller-Pilot Data Link Communication, CPDLC, is a digital way of exchanging messages, eliminating crosstalk and acoustic understanding issues. The messages or instructions are received in text. This is being used more and more. In addition to the radio communication between air traffic controller, pilot and the data link service, the communication domain deals with the following vital systems. Telephony systems are essential for the coordination with adjacent control centers and partners. Different voice communication systems link the controller working positions with the radio sites and the phone network. Broadcasting systems continuously distribute environmental information, such as weather or runway status, to all aircraft. Finally, we have the legal obligation to record all the communication in order to have the possibility to investigate in case of issues or problems. Next, let's look at the navigation domain. Distance measuring equipment, DME, showing the distance of the aircraft to the DME. The distance measuring equipment, DME, shows the pilot how far the airplane is from that navigation aid. Skyguide has many DMEs installed all over Switzerland. The Instrument Landing System, ILS, uses electromagnetic beams leading the aircraft to the beginning of the landing runway in any visibility, like in clouds or fog. Skyguide has installed ILSs at every major airport in Switzerland. VHF Omnidirectional Range, VOR. Pilots can see in which angle, bearing, they are relative to the VOR. The VHF Omnidirectional Range, VOR, is a navigation aid on the ground which lets the pilot determine his angle towards that VOR. This technology has been used for decades to enable pilots to fly procedures or find their position while in bad weather or in clouds with low visibility. Skyguide has several VORs installed throughout Switzerland. Finally, an overview of the surveillance domain. Radar, detecting the location of airplanes for air traffic control. A radar is an electronic system determining the distance of and direction to aircraft around it. This allows the air traffic controller to observe the air traffic on an electronic map. Skyguide operates different types of radars for purposes like monitoring the approaching traffic, identification, and tracking en route traffic, as well as observing ground movements on the airport. Automatic Dependent Surveillance Broadcast, ADSB. The position is automatically sent from the aircraft to ground stations and surrounding aircraft. Automatic Dependent Surveillance Broadcast, ADSB, is a surveillance technology where aircraft broadcast their identity, position, and other information. Pilots and air traffic controllers get an overview of the traffic in the air, which is dependent on the aircraft's own information. An ADSB network consists of many small antennas over a large area. Multilateration, MLAT. The aircraft can be located with an array of small ground stations. Multilateration, MLAT, is a technology to calculate the position of aircraft based on time difference of arrival of emitted signals. Signals transmitted from aircraft or ground vehicles are being used for this. Skyguide owns and operates these systems in Switzerland. They need to be checked regularly for accuracy and correct function, and they need to be renewed regularly with a lifetime of around 15 years, depending on the type. Skyguide installs, maintains and replaces this equipment at the airports and all over Switzerland to ensure a safe flight under any conditions.